All right. This week we're looking at factoring, and we're doing the notes today. So we're going to look at two types of factoring. There's a bunch of different types of factoring. You probably remember this word from Algebra 1. We're going to look at sort of just basic taking things out factoring, and then we're going to look at a quadratic factoring. So examples 1 through 6 are like the most basic type of factoring, where you're sort of given this equation, and what we want to do is we want to sort of break this equation down into things that are just being multiplied together. An example of sort of going the other way is when we distribute. So for example, let's say I gave you 8x squared times x minus 2. And I asked y'all to distribute in that 8x squared. Well, we know that we just need to multiply 8x squared times each of these things. If I were to do 8x squared times x, that's 8x cubed. If I were to do 8x squared times 2, 8 times 2 is 16. And then the x squared is here as well. And real quick, if you didn't know, when you multiply variables that are the same, you add their exponents together. So x squared times x, that was x cubed, but this is little x to the 1 power right here. All right, so what we're doing here is we're going backwards. If I want you to factor this, what you need to sort of figure out is what numbers do they have in common. And if they have numbers in common, what I mean by that is, are there numbers that both of these can be divided by? And also see if we can take out a variable. Do they have the same variable? So let's start with the number here. This is 8, this is 16. They can both be divided by 2, 4, and 8, but we want to choose 8. We want to choose sort of the biggest number, sort of their biggest common factor, the GCF. So I'm going to divide both of these by 8, and I'm going to bring this 8 to the outside. So whatever number we're sort of taking out, we bring that to the outside. 8 divided by 8 is 1, so this is just 1x cubed. And 16 divided by 8 is 2, and this is just 2x squared. So when you're factoring, when you're taking out a number, you're just, whatever number you're taking out, you're able to divide both of these numbers by. So we were able to divide both of these by 8, and we're left with 1 here and 2 here. When you do the variable, both of these terms have x's in them. And so this is an x cubed, this is an x squared. The x cubed means there are 3 x's here. The x squared means there are 2 x's here. So you can take out as many of the variable as sort of its lowest amount. So if there's 3 here and 2 here, we can take out 2 x's. So we can take out an x squared. When you go to sort of figure out what's left here, if I had 3 x's and I took out 2, well, we're left with just the 1 x now. If I had 2 x's here and we took out 2, we're left with no x's here. And we're just left with that number 2. And this is our answer. We factored this. So, this is the same example that I showed up here with the distributing. You can always check your answer by just distributing back in. You should get what you started with. So 8x squared times x is 8x cubed, and 8x squared times 2 is 16x squared. All right, so let's go to example 2. 4h to the 5th minus 12h to the 4th. So let's do our number here first. What can I divide both these numbers by? I can divide both these numbers by 1, 2, and 4. So we want to choose sort of the greatest number we can divide them by. So if I take out a 4, 4 divided by 4 is 1. So I'm just going to be left with 1h to the 5th. And 12 divided by 4 is 3. And I'm going to be left with 3h to the 4th right here. We also need to take out the variable. There are 5 h's here, there are 4 h's here. I can take out as much as my sort of least amount, so I'm going to take out 4 h's. If I had 5 here, now I'm left with just the 1 h. And over here, we had 4 h's, we took all those out, and we're just left with the 3. If I were to distribute this back in, 4h to the 4th times h is 4h to the 5th, and 4h to the 4th times 3 would be 12h to the 4th. All right, on example 3, I'm going to do sort of both the taking out the number and the variable in one step. So this 10x to the 8th minus 50x to the 7th. I can divide both these numbers by 10. That's their greatest common factor. And this has 8 x's, this has 7 x's, so I can take out an x to the 7th as well. That's sort of the lowest amount. So I'm going to take out a 10. I'm going to take out an x to the 7th. What am I left with? If I do 10 divided by 10, I'm left with 1. And if I take away 7 of the 8 x's, I'm just left with 1x, or just x. If I do 50 divided by 10, I get 5. And if I take out all 7 of the x's, it's just going to be 5 there. No x's with it. That's our answer. For 9t to the 4th minus 6t cubed. See here, the greatest number we can take out from both these is 3. And this is 4 t's, this is 3 t's, so I can take out 3 t's, a t cubed. 9 divided by 3 is 3. If I take away 3 t's from the t to the 4th, we're left with 1 t. 6 divided by 3 is 2, and all the t's are gone from that. On example 5, I can take out a 5 from 10 and 15. That's the greatest number we can take out. And they both have x's. This has 2, this has just 1. So we're going to take out a 5x. We're going to be left with 2x minus 3. So 10 divided by 5 is 2. 15 divided by 5 is 3. Remember, you can always check it by distributing back in, seeing if you end up with what you started with. Last one. Whenever you have this, you usually want it to be in standard form, so you want the highest exponent to come first. So we're going to do a quick rewrite here and put the negative 4m to the 4th first, and then plus 20m cubed. And if you ever have a negative as the first term, you're going to want to do a second rewrite where you sort of take the negative out. This becomes positive, and then you change the sign of whatever the other terms are in the equation. So there's only one other term here, but this would go to minus 20m cubed. So we haven't actually factored this yet. I just sort of got it in standard form by putting the term with the highest exponent first, and then we don't want a negative for the first term, so I took out the negative, and that changes the sign of everything sort of in there. Now we can factor this. We can divide both of these by its greatest common factor of 4, and it has 4m's here, 3m's here, so we can take out 3m's as well. So we're going to take out a 4, we're going to take out an m cubed, and we're going to be left with m minus 5. That's our answer. Okay, our other type of factoring we're going to look at today is the basic quadratic one. I don't know what you remember about quadratics. I'm going to write something right here. But they have an ax squared plus bx plus c. So a quadratic formula is when you have or a quadratic equation is when you have an x to an x to the second power. And the type we're looking at today is if it's in this complete form with the a, the b, and the c. And more importantly, this is going to be when a is 1. So this is only going to be when a equals 1. I'm going to silence my phone. All right, so if the trick to this is pretty easy. If I want to factor this, first off, we can't do what we did on examples 1 through 6 because if I ask you, what number could you take out from all 3 of these terms, there's no number that would divide into all these. You also can't take an x out of this because, yeah, these first 2 terms have x's, but this last term does not. So in order to take out an x or in order to take out a number, you have to be able to take it out from all the terms in the equation. So the secret to this one is we look at our c value and we figure out what times what gives us the c value. So the c value is always this last number. I'm going to look at 10. And I'm going to write down things that we can multiply together to get 10. We can multiply 1 and 10 together. We can multiply 2 and 5 together. That kind of looks like that's it, but don't forget about the negatives. You can also do -1 and -10, -2 and -5. And what you want to do is, out of these sort of things that we can multiply together to get our c value, so this is just called factoring the c value, you want to figure out which of these factors, if you were to add them together, gives you the b value. If I'm looking at this 2 and 5 will add up together to be 7. And so our factors are just going to be this. you put an x, you make two parentheses, you put an x at the beginning of each one, and you just take whatever these numbers are. If they're positive, you do a plus. Those are your factors. If we had more time, we would FOIL this out, and we would FOIL it so that way you could see that we end up getting back what we started with. So if you were to distribute this back out and sort of do that FOILing technique, you would end up with the x squared plus 7x plus 10. So let's get to example 8. If I ask you to factor this, again, we can't take anything out like we did on examples 1 through 6. And this is a quadratic where the a value right here is 1. So there's just an invisible 1 in front of the x squared. So I'm going to take the negative 12. The c value, I'm going to figure out what times what is negative 12 but adds up to be negative 4. Now some of y'all might be really good at this, and you don't have to write all these out, but I'm going to write every possible combination here. So we have 1 and negative 12. So 1 times negative 12 is negative 12. Don't forget that if I switch the positive negative, that also works. So negative 1 times 12 is also negative 12. Let's see here. We have 2 and negative 6. We have negative 2 and 6. We have 3 and negative 4. And we have negative 3 and 4. Those are all the possible combinations, all the possible factors of negative 12. So which of these, so then we want to look at this and figure out which of these add up to be that middle b value. I believe it's going to be 2 and negative 6. So 2 plus negative 6 is negative 4. So those are going to be the numbers we're going to use. We're going to make two parentheses. We're going to put an x at the beginning of each. And we just take these numbers, we put them in one into each parenthesis. If it's positive, like this 2 is positive, we're going to say plus 2. If it's negative, like this 6 is, we're going to say minus 6. And that's our answer. And this same pattern is just going to keep going. So on example 9 and 10, it's going to be the same deal. On example 9, can't take anything out. I'm going to factor 15. This goes to 1 and 15, 3 and 5. If you stop here, you're going to look and say, which of these add up to be negative 8? Don't say 3 and 5. Those add up to be positive 8. Don't forget you have the negative versions as well. So a negative 1 times a negative 15 is also a positive 15. A negative 3 times a negative 5 is also a positive 15. The negative 3 and the negative 5 are going to be what add up to be negative 8. And we're going to say x minus 3 and x minus 5. And then example 10, same deal. I'm going to factor negative 30. I'm not going to write them all out this time. I'm just going to think about this. What times what is negative 30 but adds up to be negative 7? And it might not be that obvious here, but it's negative 10 and 3. So negative 10 times 3 is negative 30, and negative 10 plus 3 is negative 7. Those are the numbers I want to use. We're going to say x minus 10 and x plus 3. By the way, if you write it as x plus 3, x minus 10, doesn't matter. All right. And then 11 and 12 are sort of the trickiest ones. It sort of combines the first 6 examples with these last 4 that we just did. If I'm looking at this right here, notice the a value is not 1. So this trick that we just did on 7, 8, 9, and 10 is not going to work. But we're able to factor out. And what I mean by that is, just like we did on examples 1 through 6, these have numbers in common. So all of these can be divided by 2. That's sort of their GCF. And they also all have x's. This has 3 x's, this has 2, this is 1. So I'm also going to take out an x from all these. So if I divide this first term by 2, and I also take out an x, I'm going to be left with x squared. So 1x squared. And if I divide this second term by 2, 6 divided by 2 is 3. And if I take away 1x from the 2 x's, we're left with 1x here. And this last one, if I do 8 divided by 2, I get 4. And if I take away an x, well, there's only 1x here. That's what we're going to be left with. And then the fun's not over, because we can factor this thing in the parentheses. This x squared plus 3x plus 4, we're going to do what we did in our examples 7 through 10. And so I'm going to look at my c value of 4. What times what is 4 but adds up to be 3? It's going to be none of these. Let's see here. Yeah, this doesn't work. Whoops. Here, we're going to do a quick thing real quick. We're going to change this to a minus. Change this to a minus as well. Oopsie. All right. Anyway, so what times what is 4 but adds up to be negative 3? Oh, this still isn't going to work. All right. Man, I screwed this up bad. And I'm not going to start this whole video over. All right, we're just going to cross it out. Skip. Let's go to number 12. Same type of example. This one hopefully will work for us. So, same deal. It's sort of a mess. We can factor stuff out first. We can divide all these numbers by 3. So if I take out a 3, I can also take out 2 x's from each of these numbers. So x squared is what's going to be taken out from that. 3 divided by 3 is 1. And if I take away 2 x's from the x to the 4th, I'm left with x squared as well. Then we have this 24x cubed. If I do 24 divided by 3, I get 8. And if I take away 2 x's from the x cubed, I get just x. And if I divide 60 by 3, I get 20. And if I'm taking away both x's, I'm just left with 20. All right, let's see if this works better for us. We should be able to factor this thing on the inside. So let's see here. What times what is negative 20, but adds up to be 8? I believe 10 and negative 2. Yes, this will work. And so all we're going to do is this. When you go to do this last part, you know, this thing in the parentheses is going to become x plus 10 and x minus 2. This initial thing that we took out, he's still here. He's just hanging out on the outside. That's our answer. Okay. Well, with the exception of example 11, hopefully this went okay. All right. Don't forget to go do your digital learning evidence thing on Canvas.